Welcome. This video is designed as a brief introduction to the documentation that outlines the hazards associated with the various substances you'll be working with in your laboratory course. A document such as this that covers the hazards associated with a particular substance is referred to as an SDS, or Safety Data Sheet. Now, many people still use the term MSDS, which is an older term standing for Materials Safety Data Sheet, but refers to the same thing. Before we talk about where to locate SDS documents and go over a couple of examples, there are a few things to keep in mind. First, a single safety data sheet, or SDS, is only one source of information. It is recommended that you look at multiple safety data sheets for the same substance, but from multiple sources to get a more complete picture of the hazards associated with that particular substance. Second, the use of the information found in the SDS forms should always be combined with common sense and good lab hygiene practices. And lastly, this video is only meant to serve as a brief introduction to what a safety data sheet is, where you can find them, and the kind of information they contain. While this is extremely important initial information in and of itself, you need much more training and explanation for you to fully understand and interpret all of the information found in the safety data sheets. With that being said, let's look at how you can find an appropriate safety data sheet for a substance that, let's say, you're working with in lab in your upcoming experiment. So probably the simplest way is just to Google safety data sheet for whatever you're going to be working with. So let's say that I'm going to be working with copper 2 sulfate in my upcoming lab, right? In an upcoming experiment, I'm doing my lab course. And I want to know more about the hazards associated with that particular substance. So I can Google safety data sheet for copper 2 sulfate. And you see that a lot of links come up for this. And as you browse these links, you'll notice, okay, this one's from Fisher Scientific, this one's from Science Lab, this one's from Kamen Chem, this is from Lab Chem. A lot of these are going to be coming from chemical suppliers, right, or biological agent supplier companies, because they're required to produce or have SDSs available for all the substances that they're selling. So you can click on one of these links, it'll take you to an SDS. Another way that you can access SDSs, and the way that I usually do it just out of habit, but also it's good because it'll allow us to see a couple of other aspects that are important, is to actually go to one of these chemical suppliers' websites. So I'm going to choose sigmaaldrich.com, which is one you can use. And then in the search bar, simply search for the substance that I'm interested in. So let's say copper 2 sulfate. Now when I put in copper 2 sulfate, what you're going to see is that a large variety or large range of variations of copper 2 sulfate appear. We have anhydrous copper 2 sulfate. We have the hydrated version, the pentahydrate. We have a copper 2 sulfate solution. So you're going to see various forms that this might come in, various purities, concentrations. And in general, what you want to do is choose the one that most closely matches the form that you're going to be using in lab, in your actual experiment. Right? And you got to realize that with these changes in purity, with the hydrated versus anhydrous, with solution concentration, the hazards of the substances can change. For instance, a 10 molar, which is a very concentrated HCl solution, hydrochloric acid, has extremely different hazard level than, say, a 0.1 molar hydrochloric acid solution, which is very dilute. So the hazards do vary with these different characteristics. So try to choose the one that's closest to what you'll be using in lab. But let's say that in my experiment I'm going to be using the copper 2 sulfate pentahydrate, the hydrated form of the salt. And so I can come down here, ACS reagent grade, which is greater than or equal to 98% pure. That's probably pretty close to what we're going to be using. So I'm going to click on the SDS link. Okay, so you see that this pulled up a safety data sheet. And if you compare this to the one that we were looking at, just a minute ago when we went to Fisher Scientific, let's go back and do that again so that you can compare these two. Right, if you look at this safety data sheet and this safety data sheet, immediately you can tell that the formatting, even though it's the same substance, the formatting's different. Then you're going to see that. The format's going to be different from different companies and suppliers. Now, while the information will largely be the same for the SDSs, it's important to recognize that it will not necessarily be identical. There can be variations in the SDS forms from different suppliers, and sometimes you can even have one thing say one form say one thing and then the other form say something completely different, or they can be almost opposite in how they treat a particular subsection of this or piece of information. So that's one of the reasons that I highly suggest that you refer to multiple safety data sheets from multiple sources to get a more complete picture of the hazards associated with the substance you're going to be working with, because there are variations from different sources. Okay, but real quick, let's just go through and look at some of the types of information that are given in a safety data sheet. Well, we can see we got the name, and then we get down here to section 2, and we get some kind of numbers associated with the hazards. It talks about acute toxicity, skin irritation, eye irritation, and it puts some categories with these. Now this is using the GHS classification, which is the Global Harmonized System. And in this system, generally speaking, the lower the category number, the more hazardous the substance is. Now, you have to take that in context, because in the GHS system, these different, let's say, classifications, skin irritation versus, let's say, aquatic toxicity versus acute toxicity, they may have different ranges. So while, for instance, the eye irritation may go from category 1 to category 2, and that's it, those are only 2 categories possible, acute toxicity, you can see, goes to category 3, and it may even go beyond that, like to category 4. So you have to know a little bit more about the GHS classification system to fully interpret these results, but in general, the lower the category number, the greater the hazard. I also want to point out a couple of terms that are used quite often in SDSs. One is acute toxicity versus like chronic toxicity. Acute usually refers to the hazards associated with short-term exposure. Chronic refers to the hazards associated with longer-term exposure or repetitive exposure. So just something to keep in mind. And then we get some kind of different precautionary statements that can be really useful as we're trying to ascertain the hazards associated with something. Toxic if swallowed, causes skin irritation, eye irritation, very toxic to aquatic life. We can see that matches up with the category 1 up here with aquatic toxicity that we saw. Right, so gives you some basic, if it's on your skin, if it's on in your eyes, etc. Okay, we get some molar masses, and we get down here to section 4. There's some first aid measures. This can be really useful. Knowing this ahead of time can save time should an emergency occur in the lab. Another reason to look at the SDS ahead of time. What do you do if you get it on your skin? What do you do if you get something in your eyes? What do you do if you ingest some of it? Right, so good information to know how to fight fires that may be, where that particular substance is on fire. What do you do if you spill it? How do you store it appropriately? What do you not store it with that it might react with in a dangerous way or react with and simply degrade the material? And usually actually sometimes they'll have that storage. Yeah, okay, great. We've got exposure limits, different organizations that give the recommended exposure limits in the workplace. And then under exposure controls, you see that we have some recommendations on personal protective equipment. Talk about eye protection, skin protection, handle with gloves. Okay, what kind of gloves should I use? Well, if you're planning on actually handling the material directly, nitrile rubber is recommended of this minimum thickness. And even if you're just handling it in beakers and might splash out on you or something, then it still recommends nitrile rubber of this minimum thickness. And it also gives you a breakthrough time for that particular glove material and thickness. Right, so lots of good information there. We've got physical and chemical properties of the substance, stability and reactivity. Again, this gives you more information about other substances that your substance of interest might react with, potentially in a dangerous way, substances you want to avoid mixing it with. So this is a lot of good information here. The toxicological information is an area I come to a lot to check out, and a lot of this is, all of this is good information, but I also really hone in on the carcinogenicity, which tells you, is this a suspected or known cancer-causing agent? And then reproductive toxicity. This is good for everybody to know, but especially if you're pregnant or thinking about becoming pregnant, this is a section you want to make sure that you're looking at on a regular basis. Ecological information, disposal, transport, right? You're probably not going to refer to transport very much, and regulatory information. And then this last section gives us some more ratings, some more numbers associated with the hazards, and I like that it quantifies it to some extent. Now these are HMIS ratings, which are different than the GHS that we talked about earlier. These are actually kind of in reverse, where the higher the number, the more hazardous, the greater the hazard. Right? With GHS earlier, it was the lower the number. Here it's the higher the number. So this particular substance has a health hazard of 2, which this ranges from 0 to 4, so that's kind of in the middle. And all these should be 0 to 4 ranges, so that gives you an idea. It does have a chronic health hazard, not flammable, or really doesn't pose a physical hazard. And that's it. So that gives you some really good information as you're trying to ascertain the hazards associated with the things that you're going to be working with in the lab, and therefore how best to protect yourself. Now, let's see. I want to look at one more safety data sheet. We're not going to look at very much of it, but I want to point out something with this. If I go to exposure controls for this particular substance, which you may have seen what it was, but I'm not telling you yet. If you look at this, they say skin protection, handle with gloves. Okay, if you're going to contact the substance, use nitrile rubber gloves, splash protection, even nitrile rubber. And so just from that little description, you might think, oh, whatever this substance is, this might be kind of nasty stuff. Okay, well, let's go look at what it is. It's water. Okay, and I did this to make a point. You have to understand and think about the information presented in these SDSs within the context of how they're written. The SDSs are trying to cover every permutation of every possibility. And because of that, sometimes they can go a little overboard. It can be a little overkill, right? I'm sure when you get a glass of water at home, you don't wear gloves to get water, right? You're about to drink the stuff. So you got to use some common sense when you're looking at these SDSs, because they can be, to some extent, overly done in some cases. In other cases, it could be right on point. So you've got to look at multiple SDSs for the same thing from multiple sources. If you're still not sure, talk with other people who have used the substance before, your instructor, your TA, and that will, again, help you develop a complete picture of the hazards associated with what you're going to be working with, and therefore allow you to do the best job at protecting yourself in the laboratory environment. Okay, that's it for this video. Be safe in lab, and let your instructor or TA know if you have any questions about safety data sheets.